Welcome back once again. Now we'll start with the material properties and testing part 2. So we will start the video with the creep. What is creep? Creep is the deformation with respect to time at constant load at room temperature or higher temperature. For example, when you see on certain body, on this body, suppose this is the body, and one load is placed for so many times, like for 10 years, 20 years, 10 years or 20 years, like that. So there will be, this material will deformed, slight deformation will be due to this permanent loading, and this deformation will be very slight. Why it is so? It is due to the creep, permanent load for constant period of time. Okay, so for example, fans which are hanging on the floor ceiling, and after 20 years or 30 years, the length of the hanging um, length of the hanging metal get increased little bit. This is the fan, so this length get increased little bit over period of 10 to 20 years. So this is why we call it as creep. So creep is deformation with respect to time at constant load at constant room temperature or high temperature. So for example, see on this frame 20 kg load is applied. So due to that 20 kg load, there will be instantaneous deformation. There will be instantaneous deformation. So this instantaneous deformation is WL cube by 48 EI. And after that, apart from the instantaneous deformation, there will be deformation if this load is placed over a long period of time for years. Then there will be deformation, slight deformation. That deformation we will call it as a creep. For example, if you draw strain versus time graph for crepe material, so just after placing the load on the material, there will be instantaneous deformation. So there will be this much is instantaneous strain in the body due to the placing the load. And after the load is placed for the long period of time, then there will be increase in strain over period of time. Then after that, it gets constant over period of time. Then again it is strain starts. So in first reason 1, creep resistance decreases, and in the second reason creep resistance is constant. In the third reason creep resistance increases. So creep resistance is what? Creep resistance is creep resistance is material property or solid property. So it is solid material ability to resist creep. By the virtue of creep resistance, material resist creep. So in the first reason, slowly with the time creep increases, and in this reason 1, creep resistance decreases of the material. And after certain time period, creep resistance become constant, so deformation also becomes constant and almost linear. See, almost linear deformation. And after that creep resistance increases, so deformation slightly increases. So this is neck forming. This region is neck forming. Neck formation. This region is neck formation, and this region is strain hardening. Okay, Now, how we can increase the creep resistance of material? We can increase the creep resistance of material by using high Young modulus and strength material. So, if we increase the E value and strength of the material, then we can increase the creep resistance. And fine grain material for room temperature creep resistance. If material is present at room temperature, then fine grain material we could use to increase the creep resistance. If material is present at the higher temperature, then we will use coarse grain material for creep to increase the creep resistance. And some adding refractory metal to alloys. So this we will discuss now. What are these refractory metal? So refractory metal is high melting point metal whose melting point temperature is high. So it is clear to you what is creep. Now we are going to discuss about the refractory metals. Now refractory metal. Refractory metal. So refractory metal high melting point temperature metal whose melting point is high high melting point high melting point temperature metal. Okay, for example, tungsten, that is W, whose melting point temperature is 3500 degree centigrade. Niobium, Nb, whose melting point temperature is 3200 degree centigrade. And tantalum, Ta, molybdenum, Mo. These two metal having melting point temperature is about 2000 degree centigrade. Okay, uh, for example, now see, there is one alloy 1841 high speed steel. So what is 1841? This 18 is percent of tungsten, this 4 is percent of chromium in this steel, and this one is the percent of vanadium in this steel. So 1841 high speed steel. Okay, now we'll see hardness. So hardness is the ability of material that can resist indentation or penetration or scratch on surface, and hardness is surface phenomena. Hardness is ability of material that can resist that can resist indentation, penetration, and scratch on surface. So this is surface phenomena. This is surface phenomena. And strength, is ability of material that can resist failure. And resist failure. And what is and strength is volumetric phenomena. It takes about the whole volume of the body. It is volumetric phenomena. Now stiffness. Stiffness is ability of material that can resist deformation. Ability of material that can resist deformation. Now we will talk about the measurement of hardness. How we measure the hardness. There are different methods present. So we will discuss about one by one. So measurement of hardness. First one is Brinell test. That is low hard material. Low hard material. In this we use suppose this is the metal whose hardness we want to know. Okay, this is the piece of metal. So this is piece of metal or workpiece whose hardness we want to know. This is work. And suppose this is capital dia D. So we indenter tool we will use. This is indenter tool. This is indenter tool we will use to indent on the surface of workpiece or metal. So capital D is the indenter tool diameter. Capital D is indenter tool dia. It is indenter tool diameter. Suppose capital D is indenter tool diameter and small d is indentation diameter. Indentation diameter. And the principle is area of penetration. Principle behind this test is area of penetration. How much area it gets penetrated, that will tell us about the hardness of that material. So principle is area of penetration. So this area, how much area gets penetrated, it will tell about the hardness of the material. So indenter tool and indenter tool is equals to hardened steel ball. Here we use hard steel ball. Here hardened steel ball. Hardened steel Brindle test. Hardened steel ball we will use, and applicable material, that is aluminum, mild steel, brass and copper. So whose hardness we can calculate by using this method is, that is applicable material is aluminum, mild steel, brass and copper. Aluminum, mild steel, brass, copper. So these things we can get the hardness. One thing you will note here, that the hardness or the strength of this indented tool should be higher than the material whose hardness we want to calculate. So here hardened steel ball is used, and this workpiece material is aluminum, mild steel, brass and copper. This strength is less than hardened steel, so that's why we can punch here. Okay, so keep in mind. So area of penetration, this area of penetration we can calculate by using this formula. Pi by 2 capital D means dia of indented tool, capital D into capital D minus root under capital D square minus small d square, capital D square minus small d square. We can use this formula to get the area of penetration. And hardness we measure with BHN, Brinell hardness number, and hardness we measure in this test by showing it as BHN, Brinell hardness number. And Brinell hardness number is nothing but force we apply on the indented tool. This force we apply on the indented tool by the area of penetration. So area of penetration, just write the formula. So this force we apply on the indented tool, and pi by 2, area is pi by 2, so 2 come up on here, so 2 pi d into capital D minus root under capital D square minus small d square, capital D square minus small d square. So this is the Brinell hardness number, BHN. So remember this BHN. Okay, and we measure BHN in unit of like kgf, nanometer square, sorry, or Newton per meter square. Okay, kgf per nanometer square or Newton meter square. Now we will talk about the Vickers test. This is also used to measure the hardness of a material. So Vickers test. Vickers test. So it is a very high hard material. It is used to get the hardness of very high hard material, very high hard material. And we measure it like VHN, Vickers hardness number. VHN is equals to 1.854 load applied on the tool, indented tool, by average dia of indentation. Okay, average dia of whole square. So the principle is measured based on the indentation diagonal. Suppose, see here, indentation tool is like this, and diamond indenter tool will be used here. So this is in this shape. Okay, so this is at the last diamond indenter tool. This is diamond indenter tool, and this angle is 136 degree. 136 degree. And by using this indenter tool we measure the hardness of the material. This is workpiece. This is workpiece whose hardness we want to know. This is work, and from this we punch this tool by applying force, suppose P, on the punch tool. So some indentation will be on the surface of this metal piece. So this, suppose this is the indentation in this shape. Okay, so suppose this dia of indentation is D2, and this dia of indentation is D1. Suppose this is D1. So average dia will be D average dia of indentation will be D1 plus D2 by 2. D1 plus D2 by 2. So this average we use here. Okay, now the we will talk about the principle. We will talk about the principle. So principle, it is based on indentation diagonal, as we have discussed this indentation diagonal. So the principle is based on indentation diagonal. Based on indentation diagonal, an indenter tool is pyramidal diamond shape. This is pyramidal diamond shape. So tool is indenter tool is pyramidal diamond shape. Pyramid shape diamond. Okay, now applicable material. Whose hardness we can measure. So applicable materials are silicon carbide. These are very hard itself. So this test is used to get the hardness of very hard material. So this silicon carbide is already hard in nature. Tungsten carbide, titanium carbide, and CBN and HCS. Okay, so this is about the Vickers test.
Here is information from Wikipedia.
Now we will discuss about the Now we will discuss about the Rockwell hardness. It is used for all type of materials. It is used for all type of material. Suppose one indenter tool is like this. Okay, this is indenter tool. Okay, and some force is applied P on the material. Suppose this is the work material. So this on the work material, this depth is depth of penetration. This is dp. This is depth of penetration. This is depth of penetration, and this indenter tool is conical shape diamond in Rockwell. Conical shape diamond. Okay, so principle used, it is based on the depth of penetration. Principle is the principle based on depth of penetration. Based on depth of penetration. And indenter tool use is conical shape diamond. Indenter tool is conical shape diamond. This is conical shape diamond. Conical shape diamond. And applicable material whose hardness we can get from this test. Applicable material, applicable materials are aluminum, HCS, brass, CBN, silicon carbide, tungsten carbide. So this is the Rockwell hardness test. And Rockwell hardness number is inversely proportional to depth of penetration. So remember this. Okay, so hardness test. What are the hardness tests we have discussed till now? Hardness test. First one we discussed about the Brinell test. Second one is Vickers test, and third one is Rockwell test. First one was Brinell test. Second one was Vickers test, and third one was Rockwell hardness number. Rockwell test. Okay, now we will discuss about the different other tests, different other test like Moore test. Moore test is a scratch test and its principle is qualitative test. Moore test, it is generally a scratch test. Scratch test and principle is qualitative test. Qualitative test and shore test is a shore test. Shore test, it is used for the soft polymer or thermoplastic polymers to get the hardness of soft polymer or thermoplastic polymer. Okay, now barcode test, it is used for the hard polymer and thermosetting polymer. Barcode test, it is used to get the hardness of hard polymers or thermosetting polymer. Okay, now knob test, KNOOP, knob test, it is used for the micromaterial to get the hardness of micromaterials. Okay, so in next video we will continue this topic and we will start with the fatigue. Till then, see you and we will meet in the next video.